What are design patterns? Design patterns are reusable solutions to common software engineering problems that arise during the development process. Design patterns provides a common language and framework to communicate and collaborate on complex software development projects. What are the different types of design patterns? Design patterns are divided into three main categories. They are creational patterns, structural patterns, and behavioral patterns. What are creational design patterns? Creational design patterns are concerned with the process of object creation. Creational design patterns provides multiple ways to create objects in a flexible, efficient, and reusable manner. Creational design patterns includes Singleton, factory method, abstract factory, builder, and prototype. What are structural design patterns? Structural design patterns are concerned with the composition of classes and objects to form larger structures. Structural design patterns provides multiple ways to organize and relate objects to one another in a way that is flexible and easy to understand. Structural design patterns includes adapter, bridge, composite, decorator, facade, flyweight, and proxy. What are behavioral design patterns? Behavioral design patterns are concerned with the communication between objects and how they collaborate to achieve a common goal. Behavioral design patterns provides multiple ways to manage and coordinate the behavior of objects in a way that is flexible and efficient. Behavioral design patterns includes chain of responsibility, command, interpreter, iterator, mediator, memento, observer, state, strategy, template method, and visitor. What is Singleton pattern? Singleton pattern is a creational design pattern that ensures a class has only one instance. Singleton pattern provides a global point of access to that instance. Singleton pattern is mostly used in scenarios where there should be only one instance of a class, such as database connection managers, login systems, thread pools, and configuration managers. Singleton patterns are useful for managing shared resources and enforcing a single point of control or coordination within an application. How to create a Singleton pattern? Steps to create Singleton pattern are as follows. Step 1. Make the constructor private. Means this prevents other classes from directly instantiating the Singleton class. Step 2. Create a static variable to hold the instance. Means this variable will store the single instance of the class. Step 3. Provide a static method to access the instance. Means this method will be responsible for creating the instance if it does not exist and returning the instance. Step 4. Ensure thread safety. This step is optional. Means if your application is multi-threaded, you may need to add synchronization to the creation of the instance to ensure thread safety. Here is a Java example where all the 4 steps are used to implement a Singleton pattern. Step 1, 2, 3 and 4. Give yourself few seconds to read the code. What are factory method pattern? Factory method pattern is a creational design pattern that provides an interface for creating objects but delegates the actual object creation to subclasses. Factory method pattern defines a common interface for creating objects, but the specific instantiation logic is deferred to the subclasses. Factory method pattern is useful when there is a need to create multiple related objects that share a common interface or superclass, but the exact type of object to be created is determined at runtime or by subclasses. Factory method pattern allows for the flexibility of creating different instances of objects without tightly coupling the client code to specific concrete classes. How to create a factory method pattern? Steps to create a factory method pattern are as follows. Step 1. Define a common interface or an abstract class. Means Create an interface or abstract class that defines the common methods that all products will implement. Step 2. Implement concrete product classes. Means create concrete classes that implement the common interface or extend the abstract class. These classes represent the specific products that will be created by the factory method. Step 3. Create a creator class. Means define an abstract class or interface that declares the factory method. This class acts as a factory for creating products. It can also contain other common methods or logic related to the products. Step 4. Implement concrete creator classes. Means create concrete subclasses of the creator class. Each subclass will override the factory method and provide the implementation to create a specific product. Here is a Java example where all the 4 steps are used to create the factory method pattern. Give yourself few seconds to read the code.